Hiya, I'm just going to quickly show you how to convert denary numbers to 2's complement binary. So 2's complement is a system which lets us store negative numbers as well as positive numbers, represent them rather. We learnt previously how to convert positive integers from denary to binary and vice versa, but of course computers use negative integers as well. So this system is very easy. I'm going to show you. I'll stick with 8-bit binary numbers here, but the rule's the same, doesn't matter how many bits you're going for. Whatever the leftmost place value is, in this case 128, the most significant one, we make that negative. That is it. Now we're doing 2's complement. Easy. So, if I wanted to do a positive number, all I do is I make sure I don't include that. So I'll just put a 0 under there for positive numbers. For negative numbers, I'll need to include that. I'll put a 1 under there. Let me try to show you. Try. I hope I succeed. So let's do a positive number first of all. Let's go for, 67. Just positive 67. So just same as ever. I don't want one of those. So I'll have a 64 and a 2 and a 1. Please. 64 plus 2 plus 1 makes 67. Yeah, standard stuff. What if I want a negative number? Let's go for negative 67. So I can't get negative 67 just by adding these things up. What I need to do is start down at negative 128. And then I need to add on to that. So I'll be adding up the way from negative 128. You know how negative numbers work. So negative 128, that would take me too high. That would take me to what, negative 96, I think. Negative 80, negative 72, negative 68, negative 67. There we go. That's 2's complement. I'll do a couple more for you in case you don't quite get it. So let's go for another negative number, negative 100. So I want to start down here, negative 128. Don't want to add on too much to it. That'll take me to negative 112, negative 104, negative 100. Okay, do a positive number. I'll go for positive 100. So I don't want to start with that. Just 64 plus 32 makes 96. Plus 4 makes 100. Okay, easy. So what's happened is we've still got the same as before. With 8 bits, I've still got 2 to the power of 8. Oh, excuse me, 2 to the power of 8, which is 256 values. Exactly the same as before. But whereas before, and I'm going to just sketch out here quickly, whereas before, if that's my number line, my values went from here up to here, 256. Now, I've basically just, by putting this negative in, I've shifted them down the number line. So now they're down like this, the range of possible values. Those 256 values. I've just realised I made a mistake, didn't I? 255 is the highest we can get. Foolish of me. But I can't be bothered re-recording the video. So we got 0 to 255 before. Classic. Now, what's the lowest value I can get? Well, just with 8 bits, give you a moment to see if you can work it out. It's going to be, stick a 1 in there, and not add anything on. Negative 128. So we've got negative 128 down there. And what's the highest value going to be? Well, if I don't do that, I just add all these together. 127. Okay, so the range of values that I can get has has just shifted down the number line a little bit. And if I want to do larger numbers, then I simply add more bits, 256, 512, as usual. I just always make sure the leftmost one is the negative value. Now what about converting back? Exactly the same. So if I'm given an 8-bit number that I'm told has been represented using 2's complement, so I'm just going to make one up here. I have no idea what this is going to come out. 6, 7, 8. What am I doing? There we go. Okay, we just write the place values above it, making sure the leftmost one is negative. 64, negative 128. So that is negative 128 plus 16 plus 2. What's that? Negative 110. And you might get positive numbers that have been stored using 2's complement. That's fine. You just do the exact same thing. You'll always be able to tell it's a positive number because it will have a 0 at the left hand side. But there we go. Why can't I count? There we go. And again, we just write our place values still. 1, 2, 4, 8, 16, 32, 64, negative 128. And that's just, have I got room? 32 plus 4 plus 2 plus 1. Same as usual. 39. Okay, so hope that makes a bit of sense. I'm sure I've forgotten something. Apologies for making that mistake there. I'm sure you'll forgive me. Leftmost bit, make it negative. See ya.